Okay, girls, I am just making this recording outside during lunch, so bear with me if there's some people commenting as they walk by. All right, so here's one of the examples that we didn't get to in class. So this is, the situation is that I'm giving you a 10-item multiple choice quiz to get you familiar with binomial distributions. And on this quiz, basically what you have to do is you have to guess for every single question. Okay, so the questions, I'm just going to use my calculator and I'm going to randomly generate a number and that's going to tell me what the answer is. So basically it's just how well can you guess if you have absolutely no idea on how to answer a question. So we've got Marie, she's one of the students in the class, and we're going to let X be the number of Marie's correct guesses. So the first thing that we need to do is show that this is a binomial random variable. So first of all, it's binary because the success is that Marie chose the correct answer, and there's a failure in the sense that she chose the wrong answer. It is independent because each guess is going to be independent of any other guess. I'm just using a calculator to randomly generate numbers to get the answers. There are a fixed number of trials. There's 10 questions on the quiz, so there's n equals 10. And then for each one of these, there's the same probability of success. There's one correct guess out of 5, and so for each question, you have a 1 out of 5 chance of getting it correct. Part B says, find the probability that x equals 3 and explain what this means. So because it's binomial, we just confirm that by checking bins. We can use our calculator, the binomial PDF, because it's equal to 3. The trials are going to be 10. The probability of success is 1/5, and our x value is 3 successes. And so that's a 0.2013 chance. And so what this means is that there's about a 20% chance that Marie is going to get exactly 3 out of 10 questions correct on the quiz. So she's got a pretty decent chance of getting a 30% on the test, which is not great. So you know what? In order to help you guys out, I'm going to make it so that in order to pass the quiz, all you have to do is get 6 correct answers. So let's see what the probability is of getting 6 or more correct answers would be. So because it's greater than or equal to, we're going to use our complement rule. So the probability of x being greater than or equal to 6 is the same thing as 1 minus the probability that x is less than or equal to 5. And so when we use our calculator for that, we get a 0.006 as our probability.
Oh, sorry. Are
That's
you on
okay.
the phone?
No, I'm making a video.
Oh, okay. Sorry.
Do you need something?
I was just telling you that I put the blue
I got it.
flag. Okay.
Yeah. So what this means is that there is a less than 1% chance that Marie will pass the quiz if she just guesses on every single answer. So those are not good odds. We want to find the next part. So I wrote in like green, which I can barely see. We want to find the mean of x, and we want to find the standard deviation of x and interpret those in context. So the mean of x is just NP, so 10 trials. Probability of success is 1/5, so that's 2. And then our standard deviation is the square root of NP times 1 minus P, which gives us, it looks like maybe 1.26. And so basically what this means is that the average number of correct guesses on the 10-question quiz is going to be 2. So on average, with many, many kids take this quiz, the average grade is going to be 2 out of 10, and that will vary typically by 1.26. So hopefully you're not guessing on all of your questions, because that's showing you it's not likely that you're going to pass. Okay, so let's see how much time I have left. The other thing that we didn't get to in class was finishing up this information about geometric probabilities. So we looked at geometric probabilities for the Lucky Day game, and then we saw this formula. So the probability that it's going to take exactly k number of trials to get a success is going to be the probability of failure raised to the k minus 1 power times the probability of success, because this last thing is going to be the successful trial. Everything before that is going to be unsuccessful. And all of those things are independent of one another, so we can just multiply those probabilities. Again, this is not on the it's not on the formula sheet because they basically expect you to be able to intuitively understand this concept. Okay, so always a good idea to just be thinking about what kinds of things are not on the formula sheet and have like a running list of that in your head so that when you go to take an AP exam or one of my tests that you kind of have an idea of like, oh yeah, there's a couple things that I know aren't on this sheet but are going to come up and I need to, be able to like roll through them in my head. Okay, on the calculator, the commands are very similar to the binomial distributions. Let me see if my calculator's open. Of course it's not. So I'll get that up in a second. But it's PDF when it is y equals some number of successful or some number of trials before success. And then it's CDF when it's less than or equal to. And so on the calculator, I don't know what this is. If you go to second vars, and then the easiest thing to do is to hit the up arrow, and then there's your PDF and CDF for geometric distributions right there. Okay, and it works just like the binomial distributions. The CDF is less than or equal to, so if you don't start out with less than or equal to, you need to convert it into that before you start using your calculator. Okay, so on average, how many guesses do you think it would take before we get a correct guess for the Lucky Day game? And so intuitively, hopefully, you would think like, oh, well, there's 7 days in a week, so probably on average it's going to take 7 guesses to get a match. Generally speaking, how you calculate that, how you calculate the mean of a geometric distribution is 1 over the probability of success. And so for that Lucky Day example, the average number of guesses it would take would be 1 over 1/7, which is 7. And this also is not on the formula sheet because this is another thing that is supposed to be somewhat intuitive. So just keep that in mind. Okay, here's the last little problem that we didn't get to. Let's see where I'm at.